Hello everybody and welcome to the homework helper for statistics number 7. Whoops, there it is. Well, let's go ahead and get this thing going. The very first thing we're going to do is we're going to be reviewing histograms. Remember, histograms are those bar charts so that we can track the count of things that occur. So we're going to take a coin and flip it 5 times. We're going to record a number of times the coin lands with heads up. We're going to repeat this process 20 times either by hand or by simulation using technology. This website right here is our simulation using technology. So if we're going to flip it 5 times, repeat that 20 times, etc., etc. So let me go ahead and pull this up for you. Let's see here. I got it right here. Boom. This is the link there. It'll bring you to this page here, and here you can see it right here. Rossmanchance.com applets oneprop.htm. Anyway, it'll take you to this website, and then we get to figure out how many times I'm going to do this. So how many tosses? Well, we're doing 5 times, but we're going to do that 20 times. So 5 times 20 is 100. So I'm going to do 100. Or, ooh, actually, I could do 5 tosses, number of repetitions, 20 times. There we go. And so I can draw those samples. And this is a simulation, right? It's not doing it each and every time. But here we go. So here we go. We got all attempts. 1, 2, 3, 4, 5. We've got heads once, tails 4 times. Okay, that's our last repetition. But we can actually see how many times it happened here. When we look here, we see that in all of our options, we've got 1 head 3 times. We got 2 heads 1, 2, 3, 4, 5, 6, 7, 8 times. 3 heads 1, 2, 3, 4, 5, 6 times, and 4 heads 3 times. Okay, so that becomes our data. So times that it was 0 was 0, times that it was 1 was 3, times that it was 2. I lost track already. 1, 2, 3, 4, 5, 6, 7, 8. Times that it was 3. 1, 2, 3, 4, 5, 6. Times that it was 4. 1, 2, 3. And times we got all 5 heads is 0. Okay, and so let me go back to our viewer. Boom. Okay, so here I've tallied it 0386330. Okay, and now it wants us to create a histogram of your results. Your results will be different, okay, because you're going to do a different simulation. Like, you're going to plug it in exactly the same way, but your simulation might have different results based on the coins flipping a different way. But here we go. Here we can graph it, which is essentially the same graph that we had previously. So here it's 3. Here it's 8. Here it's 6. Here it's 3. And then 0 and 0. So 3, 8, 6, 3. Okay? And then we have to describe it, okay? What is the shape? It's almost like this would be a normal distribution, right? Normal distribution would look something like this. It's close to normal. It's close to normal. My center appears to be skewed to the left, right? We're kind of slightly more to the left. It's a little bit higher on the left. My spread goes from 20 to 80. I didn't get any all zeros. I didn't get any all heads. I didn't get any all tails. So those didn't happen. All right. Okay, so let's go ahead and look at this. Let's flip 20 coins. We'll record the number. Whoops, let me get that on screen. Let's flip 20 coins, or a coin 20 times. Record that number of times it lands heads up. Repeat this process 20 times, either by hand or by simulation. So again, we can use simulation. So this time, we're being asked to flip a coin 20 times, so the number of tosses is not 5 this time, it's 20. And we're asked to repeat it 20 times as well. So we're gonna draw this sample. Boom. All right. And so here is our data. Here is the number of times. I wonder what these buttons do. 2-sided? No. Exact binomial? Ooh, look at that. Normal approximation. So that's how we'd look at a normal curve. So we can see that this specific sample, we skewed right. We hit 12 a whole lot when we were expected to hit 10 a whole lot. Let's run another simulation. I'm going to draw samples. Boom. Aha, this one is a little bit more flat. Let's draw another sample. Boom. Ooh, a little bit more narrow. 12 still happening a lot. Interesting, interesting. So this is kind of fun. I could do this all day. Anyway, using this data, we'll be able to look at all of this. Let me go back to the main screen. Main screen, there we go, cool. So using whatever we did, we can then see how many times it came up 0, 1, 2, 3, 4, etc. And so we're gonna have a more precise histogram as we're looking at a larger number, a larger sample. We're looking at a larger number of possible ranges. And so once again, we'll use that, create a histogram from it. All right, we're gonna go back to using a simulation here. So in 1963, NBC started a game called Let's Make a Deal. Okay, the rules of Let's Make a Deal are pretty simple, okay? You're pretty much, there's a prize. There's some sort of prize. I don't know, what's a prize? Do I have anything on my desk that anybody would possibly want? Probably not, but let's just say, here we go. You're given a prize. Okay, and for this case, here we go. We're gonna say that the red pen cap is more desirable than the green pen cap. And essentially how this game would work is each of these would be placed in a box, okay? And you wouldn't know which one was which, okay? So they're all placed in a box. And then you'd pick a box. And you'd say, you know, door 1, 2, or 3. You'd open, you'd pick your door, and they would show you a losing door. Okay, they would show you a losing door. And then you would have the option to stick with your initial pick or pick a different one. And so this simulation does a really good job on this. So what it wants you to do here is play the game 20 times sticking and play the game 20 times switching. So let's go ahead and go to that simulation. Right here, it's called the Monty Hall game. Let's make a deal. So here it is, here's the 3 doors. You're allowed to pick one door. So I'm gonna pick the middle door. So I pick the middle door, it shows me that the right door has a goat, has nothing that I want. Now I have the option of either staying with my door or switching to the other door. So if I stay with the door, I lost, I got the goat. We're gonna play it again. Okay, do I stay with my door or do I switch? I'm gonna switch. Oh, I win. I'm gonna play again. This time I'll stay. Play again. This time I'll switch. I'll play again. This time I'll stay. I lost. This time I'll switch. I lost. This time I'll stay. This time I'll switch. Okay? And so what you see here, stay, switch, stay. I'm gonna keep doing this for a while. Switch, stay, switch. So I've stayed 7, I've switched 7, let's stay 10 times, let's switch 10 times. And I'm not even looking at how each result is going. I'm just looking at this here. And what do we see? What do we see? Look at the differences between our wins and losses versus stay and switch, okay? So you can continue to play this game, and it wants us to do it for 20 times each. Okay, I can actually do that for us. Let's stay, 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 stay. And I'm just looking at this number here. Stay, stay, stay. Okay. And now I'll switch, 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 switch. And one more switch, switch. So now I have 20 and 20, and look at how dramatically different our stay versus our switch wins and losses are. And so what we find out is that this isn't actually, it is a random game. There is elements of chance, but it's not completely random. You can actually make some choices, and it's actually a very interesting problem, because think about it this way. You pretty much, when you pick one of the doors to start with, here, I'll throw up the picture here. I'll throw up the, boom. So if we have 3 doors, and you pick a door, your initial pick only has a 1 in 3 chance of being correct. This is a 1 in 3 chance of being correct, okay? But then what ends up happening is one of the doors is eliminated, okay? This door becomes eliminated, all right? So we know that either this or this is our correct answer. Well, what does that mean? Well, that means the other door has a 50% chance of being correct. Well, yours only had an initial 1/3 chance. So it is always correct to switch doors because then you have a 50-50 shot as opposed to a 1 in 3 shot. And we'd rather take the coin flip, right? So go ahead and look at this, build your table, look at how it works versus sticking or switching. And this is a very famous problem, and I find it super cool. You'll need to build your data from this. If the website doesn't work, because the website given here, I should actually note this. The website given here is a dead website, but I emailed, this is 2019, I emailed you what you were supposed to do. If I didn't, if this is a future class that's watching it, this is the web page that you need to go to, Rossman Chance, Applet, Monty Hall, Monty 04. But this is the exact data. So if I were doing this, I would put stay, I had a total of 20, stick is, or I'm sorry, how does it say? It's stick on the paper, but it says stay here. This is the same as stick. So that would be 20. That would be 20. Yeah, it would just be the exact same. So we would fill it out. 20, 14, 6, 20, 40, 21, 19. We'd fill it out just like so. Let me pull up the image. Boom. So we would convert that image to that table like this, and from that we can start to do probabilities. You know, if you stick 20, what's the probability of winning? 7. If you switch 20, probability of winning 14. It's like twice as good. It's even better. So give that a look, and we can mathematically prove that switching is the better strategy. So that's it for today. That's it for this lesson. That's it for this unit. Good luck on all of this, and see you next time.